Hi, in this session we are going to cover the introduction to machine learning as we introduce the subject of machine learning techniques. And the objectives that we intend to cover in this session is what is machine learning, what is big data, machine learning lifecycle, and a brief about machine learning techniques or types. When we are looking at machine learning, it can be viewed as just the development of computer systems that have got the ability and capacity to learn from data with the objective of making inferred decisions that come from the patterns that are discovered in the data without being explicitly programmed and by making use of algorithm and statistical models. Machine learning is a subset of artificial intelligence. And then we talked about machine learning making use of data. And when we look at and view the world as it is, we discover that there's a lot of information or a lot of data that is created each and every second online. And this data comes in large data sets, and most of it comes in different formats. And this is exactly what we are talking about. We are looking at an extremely incredible large data set. This data set is too valuable to be left unanalyzed. And we would want to gain insight and take advantage of all the information that is hidden inside this big data. And most of the time when we are looking at this big data in terms of its characteristics, it becomes too complex for it to be analyzed using traditional methods and tools like spreadsheets. To clearly understand big data, we have to look at its characteristics. I'm going to look into 6 V's of big data, which are the characteristics of big data. One of them is volume. You'll find that data is generated online and even using systems in our organizations, using different gadgets that we use in our community as individuals, and its volume is too big. We are looking at the amount of data that is too extremely huge. And when we are looking at the variety, we are looking at the different types of data that is generated. Some of it is structured, some of it is unstructured. We are looking at the various types of data in which it comes through. Some of it is text, some of it is coming through structured database systems of our systems in different organizations. Some of it is coming from audio, the likes of the TikToks of this world, generating different videos and images. So this is the variety of the big data that we would want to take advantage using machine learning techniques to come up with inferred decisions, rather than coming up with thumb-sucking decisions or decisions that are related or that come from mental shortcuts where people use only past experience or the guessworks of this world, or coming from gut feeling. And let's look at the third V, which is the velocity. We are looking at the rate at which data is being generated. And according to some online sources, if we're going to go back into something like 2023 or 2024, you will find that there is a lot of data that is being generated every minute online, and you can always search for something like data being generated online in 2024, and you will see that data is being generated in large volumes. So when we are looking at that volume of it and the rate of the speed at which it is being generated, you will see that almost every second, most people are online, and they are creating or generating information, posting some communications, charts, images, and so forth. This is velocity. And then when we are looking at the other V, which is variability, we are looking at the irregularities that are found in data, for example, due to noise. So the data, when it is produced, it has got some different, it doesn't have a standard format of the data that is coming through. There's a lot of missing data, and there's a lot of information that could be classified as noise inside the data that you are trying to analyze and make use of. The other V is veracity, and at this point we are looking at the trustworthiness of the data. Is that data, everything that we have inside that, can we trust and rely on it? And the last V that I would like to look into in this session is I've bolded that to classify it as one of the biggest V when we are looking at the subject of data analytics, and this is value. What we intend to do eventually, after gathering all the information, the data that we have, and using machine learning, is to get value or the importance of data. So the other V there is value. So let's go back now and look at machine learning, now that we understand what big data is, and when we are looking at coming up with systems that are able to make use of data to make decisions. Now let's look at the life cycle of machine learning. When we are talking about life cycle of machine learning, from the word life, it means to say it's not a one event thing. It's a continuous process. It's continuous to go, and we're looking at a cycle. It means to say we continuously repeat these processes over and over again. And when we are looking now at the machine learning cycle, basically I've come up with 7 steps in machine learning cycle, and the first one being the business understanding. At this stage is when you would want to look at the problem statement that needs to be solved, the goals, objectives of the organization, or the challenges of the business, trying to get into the feasibility study of the problem that is that the organization is facing, that you intend to solve. Once we have the understanding of what needs to be done, what needs to be solved, what is the current situation, the problem that is on the organization or at hand, we now move on to stage number 2, whereby then we need to look into data collection, and we are now looking into the various data sources that might be available for us to solve that particular problem in stage number 1. So this could be data collected internally or externally, or you can collect it from different formats such as APIs, and you can collect it from different online resources, maybe using crawling and so forth, using structured data sets and so forth. So at this stage number 2 is you are collecting the data. And once we have collected the data and that we think that the data can provide solutions required to solve stage number 1, we then move on to stage number 3, which I labeled data preparation. And at stage number 3, which is data preparation. There we are looking at basically some functionalities or some stages such as visualization, where you then collect your data, you then want to analyze, to visualize the data, to see the presentation of data, how the data looks like, making use of various techniques and tools in data analytics or machine learning techniques. At this stage, you then want to see if they are missing data, if the data is screwed in some way. You want to visualize to see the data, how it presents against maybe target variables. And once you have analyzed the data and you understand how the data is presented, and if the data is balanced in some form to solve your particular problem, you then want to implement some various data cleaning techniques in order to make sure that your data is able to create a machine learning model that is able to perform well or to produce required better results. And soon after cleaning your data, you might want then to implement a feature engineering as a process, whereby then you need to use different techniques, where we are saying not every feature or not every attribute of the data that you find is going to be used in terms of machine learning, creating a model, because data on its own, as we have seen, that it comes in different formats, and it also comes with some irregularities within it. You then need to apply some different techniques, such as a selection of the best features that is going to solve your particular problem, or you might want to alter, change the data. You might want to fuse in or transform the data in some way. So this is the process of feature engineering that you'll be doing, and until you come to a position where you then select a few features that you are going to use to proceed to stage number 4, which is model building. When you are at stage number 4, model building, you then want to say, depending on the particular problem that needs to be solved in stage number 1, you then select a particular model or particular algorithms that could be used to solve your particular problem. And then you, at this position, the data that you have collected in stage number 3, you also want to then split it into training data set and test data set at this position, whereby when you take the training data set that has been split, you then want to train the model using the training data set. And you'll find that as you are training your model, you will be playing around with the hyperparameters, which is what to call hyperparameter tuning of them, the model that you are building, as you adjust it, because as you are training the model, you will find that the results that are coming out, you then want to validate and test to see how the model is performing. So you'll find that during the model building stage or the training, some might call it training and validation process stage. We are saying that component of the training data set, of which most of the time by default we would prefer to use 80% of the whole data set that we have. So 80% of it, you have 100% data set, you split it into 2, whereby 80 you use it for the training, and out of that training data set, another component of the training data set is going to be used as a validation data set, whereby we are training the model and then you want to validate how it is performing. If it is not performing well, you then want to do what we call hyper tuning until it comes to a position of which you are comfortable to say that the model is in a position to perform well given unseen data. When you reach that position, you then want to move from stage number 4 into stage number 5. At stage number 5 is when you now need to take the component of the data set which we have classified as test data set, where we say that when we stage number 3 we have produced our data set, we split it to maybe into 80% training data set and 20% into test data set. So we now need to use the 20% of the training data test data set to test the model on unseen data to see if it is now able to perform. Because while it was in stage number 4, you'll find that as it was training itself, it was using the same component of the validation data set, which it had already seen. It has got insights into how it looks like. So the component of its validation is not, it has got some bias in it. So the moment we shift to position stage number 5, we are now using unseen data set to test the model that we have built in stage number 4. And during that process, we then want to find out or evaluate how it is performing, depending on different techniques and skills depending on the type of the problem being solved. Once we are satisfied with the results of the model performing at stage number 4, where we are presenting to it and see data set, and which we feel that the data set is more realistic to the world, and we are comfortable with the percentage of the results, we then move to stage number 6. And stage number 6 is model deployment, where we now want to integrate the model with the universe to make to then take advantage of the model and the algorithms to make informed decisions coming from data. Once we have deployed the model, we do not end there. We then want to go into stage number 7, which then makes it to become a life cycle, where we are now looking at the maintenance and improvement stage, where we are saying once we have deployed the model, we then want to maintain and to observe, to monitor the model to see if the model continues to perform as expected, taking into cognition that data continues to change and results also might continue to change. So we then want to also go forth and to check if the model still performs as expected, and also review the business objective and the problem statement if it has not changed, so that we then want to improve the model by doing or going through the cycle once again. Let's now look at the machine learning techniques in brief. So you'll find that now that we understand the life cycle of the machine learning, we also want to look into what we call the machine learning techniques, or the types of machine learning. And basically, I'm going to look into 3 types in a brief, where we have got what we call supervised learning of machine learning. And basically, when we are looking at supervised learning, we are looking into machine learning whereby the algorithm is presented with what we call labeled data set. In other words, the data set that we're giving to our model, it has got the outcome presented in it, so that the model is able to then learn while it's verifying with the labeled data or the output result as it learns. So we call that supervised learning, and this can be classified into 2 categories, which is classification and also regression type of of learning. And then we have also what we call unsupervised learning. In other words, at this position, we are using unlabeled data set that is going to be sent to the algorithm for it to try to learn. And usually, unsupervised learning is used in events or categories of clustering problems that we need to solve. The third is type called reinforcement learning, and this type of learning is usually used where we want to do decision making. And what happens with this reinforcement learning is we are looking at an agent that we would want to give an opportunity to explore into a given environment, and we allow it to learn by ways of making mistakes and errors, and the whole learning process. We then provide feedback to the model. The feedback which might be in terms of an award or in terms of a punishment, and this agent tries by all means to get positive rewards rather than taking punishments. And as it continues to do the self-learning, it then improves itself by way of trying to gain more of the positive awards versus the negative awards. So we call it reinforcement learning. This brings up and wraps up this session's objectives. So thank you so much. If you like this session and you look forward to more sessions when we are going to look into the various machine learning techniques in Jupyter Notebook, please kindly like this channel. Also remember to subscribe so that you won't miss when we are going to look into various skills such as exploratory data analysis, how you clean up your data, how you fill in your data, how you do feature engineering. We are also going to look into the deep learning. We are going to look into the convolutional neural networks, and the various machine learning techniques that we are going to implement. So kindly subscribe to the channel. Cheers.